All right, we're at the beginning of the videos as promised, and we're going to start at the beginning. So the first thing maybe we should talk about is what even is statistics, right? So we think about collecting, analyzing, and then drawing some conclusions about some data that we maybe are interested in, okay? So first, we probably need to think about what are we studying? Are we studying people? Are we studying animals? Are we studying things? Those are called our individuals in the study. Then we move on to what are we actually studying here? What attribute are we interested or what attributes are we interested in about those individuals? And those are called our variables. There are two kinds of variables. As you can see, we talked about categorical, which just means we can categorize it, but we can't measure it. And then quantitative, which are measurable variables. After we decide on an individual we want to study, and a variable about that individual we want to study, and we've figured out what it is that we're studying, we need to think about how are we going to analyze the data. How are we going to examine that variable about the individual, right? So to do that, maybe we want to create graphs, maybe we want to find numerical summaries, and so that leads us into beginning to look at our sort of one variable statistics on our individuals. Okay, so hold on tight. Okay, so we're going to look at analyzing categorical data, and we're going to start with only one variable, which is probably the simplest of all, kind of that middle school thought of what can we look at. So let's look at some totally made up data. Let's say that I asked 12 random people, don't care about ages, don't care about gender, don't care about any of that right now. I'm asked 12 random people what they like better, Instagram, Twitter, Snapchat, or Facebook, okay? And so I get these results, totally made up results, and this is categorical data, not quantitative data. I tally it up, so that's the first step, tally it up. How many people liked Facebook, Twitter, Snapchat, Instagram? After I tally it up, then I organize it. Think about it being in a table. I can think about it a couple of different ways. I can think about the frequency, right? So one person liked Facebook, one person liked Twitter, four people like Twitter, 4 people like Snapchat, 3 people like Instagram, right? Then maybe frequency isn't really descriptive enough for me, so maybe I want to know a little more. I want to compare it to everybody else. So I might say, okay, 1 out of the 12 people liked Facebook, or 8%. That is called relative frequency. So it's frequency relative to the rest of the individuals. Then 4 out of 12 liked Twitter. So you can see me turning this into percentages, or I could use decimals. Either one is perfectly fine. And when I'm done, I should have a total of 100%. And I know what you're thinking right now. These don't add up to be 100%. And that's because I rounded some decimals on the 33% and on the 8%. So that's where my percent is lost. So that's fine. Okay. After I've collected my data, tallied my data, organized my data in some kind of way, then I probably want to display my data in some kind of graph. 2 main graphs for one variable categorical data as a bar graph and a pie chart. So in order to do a bar graph, remember, be very descriptive. X-axis, Facebook, Twitter, Snapchat, Instagram. On the y-axis, the percents. I started 5%, 10, 11, 5%, 10, 15, 20, 25, 30, 35% was enough. Remember, your bars need to be the same width, and you want to make sure you label it. And I don't have room on here, you can see, but I would want to label my graph with like social media preferences or something like that. If I'm doing a circle chart, and this is a terrible one, it's just really quick, doesn't even look like a circle, make sure that it's representative of everybody in, or every individual in the tally. And remember, you actually have to do the percentages times the 360 degrees. I did not do that here because I didn't have time. But this is how I would analyze one variable categorical data. Okay, hold on for more than one variable. Okay, we are going to look at analyzing categorical data for more than one variable. So more made up data. So let's say we ask a bunch of people, we'll call them respondents, do you own a car, truck, or neither? And then I'll also ask them, do you recycle? Okay, so maybe we're looking for relationships between what kind of car you own and if you recycle or you don't recycle, right? So first thing we want to do is record it, and the way we're going to record it is we're going to use what's called a two-way table. So two-way table looks like this. So let's say we asked all these respondents, let's say we asked 1,526 of them these two questions, okay? And this is the data that we got, the red, okay? We said 445 people own a car but do not recycle. 212 people own a car but do recycle. Okay, so we got all of this, and then in black here you can see I took marginal totals. So there were 657 car drivers, 574 truck drivers, 294 neither truck nor car, 1,221 people said nope, I don't recycle, and 305 people said yep, I recycle. And that gives us, no matter whether we go this way or this way, that should give us 1,526 respondents. Okay, there's a couple of things that we can look at here. The first two that I want to talk about have to do with relative frequency, and anytime we talk about relative frequency, we're saying relative to all the individuals in the study. Relative to all the individuals in the study. So if it's marginal relative frequency or if it's joint relative frequency, our denominator is going to be 1526 because that's the total number of respondents in the particular study. Let's say we start here with marginal relative frequency. So the formal definition of that is the percent or the proportion of individuals that have a specific value for one categorical value. Okay, so we could, for example, ask what percentage of the study or of the individuals drove a car, right? So that would be 657 out of 1526. Or what percent of individuals said yes to recycling? So that would be 305 out of 1526. So that's one thing that we can look at, and that's called marginal relative frequency, because what I need to do is I need to sum up values in the margins, and I'll be using only marginal values, right? Only totals that I got in the margins. The next thing we look at is joint relative frequency. So the formal definition of that is the percent or proportion of individuals that have a specific value for one categorical variable and a specific value for another categorical variable, right? So now we're taking into consideration two variables that are happening at the same time. For example, I said yes and own a car. I said no and own a truck, something like that, right? So an example of this would be the percent of people or the proportion of people in the sample who do not own a car or truck, but also recycle. Do not own a car or truck, but also recycle. And I know that's kind of hard to read. So if I go to my table here, if I do not own a car or truck, that means I'm looking in the neither column. But if I do recycle, I'm looking in the yes column. So one variable is I don't own a car or truck. The other variable is yes, I do recycle. And that leaves me with 16. But I'm still talking about relative frequency. And the reason, or the way that I can tell I'm talking about relative frequency, is that first line in the determination of what you're finding. What percent of people in the study? What percent of people in the study? So anytime it begins with the percent of people in the study or the proportion of people in the study, it's going to be relative frequency. Relative to all of the people in the study, how many of them either have this marginal frequency or this joint frequency, right? So the joint is two things are happening at the same time. Marginal is it's happening all in the margins. Okay, so let's look at what happens when it's not relative frequency. It's not relative to everybody in the study, but maybe just to a specific portion in the study. So hold on for that. So the other way we can look at the two variable or multivariable categorical data when we're sort of summarizing for a two-way table is to think about conditional relative frequency. Okay, so we're still using the word relative frequency, but we're throwing the word conditional on the front of it. So now our relative frequency is going to be conditional on one specific variable, right? So we're not going to use that total anymore. So our formal definition of a conditional relative frequency is the percent or proportion of individuals that have a specific value for one categorical variable among individuals who share the same value of another categorical variable. So that's really wordy and a little confusing, but an example of that might be the proportion of car owners that also recycle, right? So if I'm looking at my table, I'm looking at all the car owners. Remember, you always start with what the sentence starts with. So I'm looking at all the car owners. There's 657 of them who also recycle. There's 212 of those. And so the proportion of car owners who recycle would be 212 out of 657, which is 32%. But if I flip that, so somebody once asked about, does order matter? And I don't think I answered that very well. Yes, it does matter. So if I instead ask the question, what's the proportion of people who recycle and also own a car, right? So now let's look at all the people that recycle. There's 305 of them in this study. 212 of them drive a car. Remember, this is totally 12 of the people that recycle also or do own a car and drive a car. So if we look at that percentage, that's like 70%. Can't read my own handwriting here, which is much higher than 32%, right? So then we begin to ask about association. Can we say that if you're a car owner, you probably recycle? Or can we say if you recycle, you're probably a car owner, right? So I don't know that we can say if you're a car owner, you probably recycle. But we might make a convincing argument about you recycling. And then if you do recycle, you probably also own a car, not a truck. How do we display it? You can do this side-by-side bar graphs, which I think everybody's pretty comfortable with. I actually like this stacked bar graph better. It's percents, right? So if I displayed yes, I recycle versus no, I don't recycle, I can very quickly see if blue is car and red is truck and purple is neither. A vast majority of the yesers, I recycle, drive a car. If I don't recycle, I mean, there's a little bit of difference, but not a huge difference, right? So again, you begin to ask about association. Is there some association between if I recycle or if I don't recycle and the type of vehicle I drive? And if these two bars were pretty much the same, we might say, nope, I can't say based on the car you drive if you recycle or if you recycle, I can tell you something about the car you drive. Couldn't say it. But because there is a difference in these two graphs, because they're displaying something different, then there's going to be some kind of association. And now it's up to me as the statistician, or maybe even the researcher, actually not me, to figure out what is that association. Then we need to dig deeper.